In this module, learners will be able to 1. Understand the technological innovations that are shaping the future of forestry. 2. Learn about the benefits and challenges of these innovations. 3. Identify the potential impact of these innovations on the forestry industry. 4. Describe the environmental, social, and economic challenges we face today, and explain how the sustainable revolution can help to address these challenges. 5. Describe the technologies and practices that are central to the sustainable revolution, such as renewable energy, sustainable agriculture, and the circular economy. 6. Identify the skills and knowledge needed to implement the sustainable revolution, such as systems thinking, sustainable design, and collaborative problem solving. Now, let's get started. The forestry industry is undergoing a period of rapid change, thanks to the introduction of new technologies. Drones, GPS tracking, and big data analysis are all being used to transform the way forests are managed and harvested. These technologies are improving efficiency, reducing costs, and making forestry operations safer and more sustainable. The drones can be used to monitor the health of trees by collecting data on leaf color, canopy density, and other indicators of health. Detect early signs of disease or pest infestation, which can allow for early intervention and prevention. Map the terrain of forests, which can help with planning and decision-making. Perform tasks too dangerous or difficult for humans, like tree planting and firefighting. Count the number of trees and measure their size and volume. GPS tracking devices are attached to trees, allowing forest managers to track their growth and health over time. This information can be used to make decisions about when and how to harvest the trees, and it can also help to identify areas of concern, like areas with poor soil quality or excessive pests. It is also being used to monitor the movement of forestry equipment, which can help to improve efficiency and safety. Furthermore, big data analysis is being used to process large amounts of data collected from forests, such as satellite imagery, climate data, and inventory data. This data is used to create detailed maps and models of forest conditions, which can help with planning and decision-making. This module will explore these innovations and their impact on the forestry industry. The era of the sustainable revolution. The sustainable revolution is the idea that we need to make a fundamental shift in the way we live, work, and consume in order to create a more sustainable future. It's a response to the many environmental, social, and economic challenges we face today. There are many different aspects to the sustainable revolution, from renewable energy to sustainable agriculture to sustainable fashion. The sustainable revolution is a period of rapid change, driven by the need to make forestry operations more sustainable. This is being driven by a number of factors, including 1. Concerns about climate change and the need to reduce carbon emissions. 2. A growing demand for sustainably produced wood products. 3. The need to protect biodiversity and prevent deforestation. 4. The need to create jobs and boost economic development in rural areas. Different aspects of the sustainable revolution are the need for 1. Sustainable materials and products. This includes everything from sustainable building materials to sustainable textiles. It also includes the use of biomaterials, which are materials derived from living organisms. An example is cross-laminated timber, CLT, which is a type of engineered wood product made from layers of lumber glued together. CLT is stronger and more fire-resistant than traditional wood products, and it has a lower carbon footprint than concrete or steel. It's also a renewable resource, making it a sustainable option for construction. Another example is bamboo fabric is made from the pulp of bamboo plants. Bamboo fabric has many benefits, including being biodegradable, antibacterial, and UV resistant. It's also soft and breathable, making it a comfortable choice for clothing and home goods. Also, biomaterial, spider silk, which is being explored as a potential alternative to traditional textiles and plastics. Spider silk is incredibly strong and elastic, making it a promising material for a wide range of applications. It's also biodegradable, making it a more sustainable option than many synthetic materials. 2. Renewable energy. Renewable energy sources, like solar, wind, and hydroelectric power, are becoming increasingly important as we seek to reduce our dependence on fossil fuels. Renewable energy is a key part of the transition to a low-carbon economy, and it has many environmental and economic benefits. Hydropower is the use of the energy from flowing water to generate electricity. The two main types of hydropower, impoundment and diversion, use a dam to store water in a reservoir and then release it through a turbine to generate electricity, while diversion uses a weir or other structure to divert water from a river or stream to a turbine. Dry steam uses steam directly from the ground to spin a turbine and generate electricity, while flash steam uses hot water from the ground, which is heated and then turned into steam. The steam is then used to spin a turbine and generate electricity. Biomass is the use of organic materials like wood, agricultural waste, and animal manure to generate electricity. Biomass can be burned directly to generate electricity, or it can be converted into a gas called biogas and then burned. As the era of the sustainable revolution unfolds, it's clear that there is still much work to be done to create a truly sustainable future. However, the progress made so far is encouraging, and the potential for further innovation is exciting. While the path to a sustainable future may not be easy, it is certainly worth pursuing for the sake of our planet and future generations. Remote sensing and monitoring tools. Remote sensing and monitoring tools can be a key part of achieving a sustainable future. They can help us monitor the health of our environment and make informed decisions about how to protect it. These tools can be used for a variety of purposes, from studying the environment to monitoring weather patterns. They can even be used for security and surveillance purposes. There are many different types of remote sensing monitoring tools. They are: 1. Satellite imagery. Satellites can collect a wide range of data about the Earth, including information about vegetation, land cover, water resources, and more. This data can be used to monitor changes in the environment, detect areas of concern, and make informed decisions about how to manage our resources. 2. Drones. These are unmanned aerial vehicles that can be used to collect data about the environment. They can be equipped with a variety of sensors, including cameras, LiDAR, light detection and ranging, and a monitor. This data can be used for a variety of purposes, including land use planning, environmental monitoring, and disaster response. Drones can collect high-resolution images and videos of the ground, and they can even be used for 3D mapping. 3. Optical remote sensing. This is the type of remote sensing that uses visible light to collect data. It's used for things like aerial photography, monitoring vegetation, and mapping land cover. 4. Radar remote sensing. It is a type of remote sensing that uses radio waves to measure and map objects on the Earth's surface. Radar waves are sent out from a sensor and then reflected back to the sensor when they hit an object. By measuring the amount of time it takes for the waves to return, scientists can determine the distance between the sensor and the object. 5. Thermal remote sensing. Uses infrared radiation to measure the temperature of objects on the Earth's surface. Infrared radiation is a type of electromagnetic radiation that's invisible to the human eye. It's emitted by warm objects and can be detected by sensors on satellites. Sustainable logging practices. Sustainable logging practices are those that aim to preserve the long-term health of forests, while still allowing for a reasonable level of harvest. Sustainable logging is important because forests play a vital role in maintaining the health of the planet, by providing habitats for wildlife, storing carbon, and regulating the climate. Sustainable logging practices include things like selective harvesting, reforestation, and eco-certification. 1. Selective harvesting means choosing which trees to harvest, based on factors like age, size, species, and overall health. It's important to choose which trees to harvest carefully, so as not to disrupt the natural balance of the forest. 2. Reforestation is the process of planting new trees to replace the ones that have been harvested. It's important to ensure that the forest continues to thrive and provide all the environmental benefits it can, like storing carbon, regulating the water cycle, and providing habitat for wildlife. Reforestation can be done by both natural regeneration and by planting new trees. 3. Eco-certification is a process where an independent organization evaluates a forest and its logging practices to make sure they're following sustainable and ethical standards. If the forest meets these standards, it can be awarded a certification, which shows that the forest is being managed in a responsible and sustainable way. Emerging technologies for forest conservation. There are many emerging technologies that are being used to help conserve forests. Some of these technologies include satellite imaging, LiDAR, light detection and ranging, and drones. 1. Satellite imaging is a powerful tool for forest conservation because it allows scientists to track the health of forests over time and detect changes in the landscape. For example, satellites can be used to detect deforestation, forest fires, and illegal logging. They can also be used to monitor the health of individual trees and identify areas where trees are struggling or dying. 2. LiDAR stands for light detection and ranging, and it's a remote sensing method that uses laser pulses to create detailed 3D maps of the Earth's surface. These 3D maps can be used to measure the height, density, and other characteristics of a forest canopy. LiDAR is especially useful for monitoring areas that are difficult to access on foot, like mountainous or swampy terrain. 3. Drones, also known as unmanned aerial vehicles, UAVs, have many applications for forest conservation. They can be used for a number of things, including surveying forests, detecting forest fires, and assessing forest health. Drones equipped with multispectral cameras can even be used to detect invasive species and diseases that are affecting trees. Because they can fly over large areas, drones are especially useful for monitoring remote or inaccessible forests. In conclusion, forestry is a field that has benefited from a range of technological innovations in recent years. These innovations have led to improvements in forest management, forest inventory, and forest conservation. New technologies, such as remote sensing, LiDAR, drones, and GIS, have allowed for more efficient and accurate data collection and analysis. In addition, these technologies have helped to create detailed maps and models of forests, which has allowed for more effective forest management. Drones, in particular, have been used to collect data on forest fires and to help monitor illegal logging and deforestation. In addition to these technologies, new genetic technologies have been developed to help improve forest conservation. By understanding the genetic diversity of forests, conservationists can make more informed decisions about how to protect and restore forests. Innovations in agroforestry and reforestation have also helped to increase the resilience of forests and their ability to adapt to climate change.